projects. In this video, we are going to explain about a project titled Classification of Software-Defined Network Traffic to Provide the Quality of Service. The introduction of this project is to improve the quality of service in software-defined networks by accurately classifying the network traffic. This is achieved by utilizing a combination of classifiers such as SVM, random forest, and J4A decision tree. The project involves several steps, including pre-processing the dataset, dividing it into training and testing, and applying the ensemble algorithm. The ultimate aim is to optimize the resource allocation and enhance the network performance through the detailed traffic analysis. The main goal of this project is to enhance the quality of service by classifying the network traffic based on its application. The aim is to identify and filter out unnecessary traffic, allowing only the traffic that is required by the user. Additionally, the project aims to prioritize the essential applications, ensuring they achieve the preferential treatment in terms of network resource and performance. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to implement this project. The first module is Upload Network Traffic Dataset. This module allows the user to upload a network traffic dataset to the application. This dataset contains the information about the network traffic such as source, destination IP address, ports, protocols, timestamps, etc. After uploading, the module analyzes its contents and extracts the relevant information for further processing. The second module is Dataset Pre-Processing. This module is responsible for pre-processing the dataset before using it for machine learning algorithm. It handles the tasks like handling the missing value, which involve filling in or removing any incomplete entries in the dataset. This module also performs the normalization, which scales the dataset values to a standardized range, typically between 0 and 1, to ensure the fair comparison between the different features. Additionally, non-numeric data present in the dataset is converted to numeric values using the label encoding. This process assigns a unique numeric label to each distinct non-numeric value, enabling the machine learning algorithm to process the data. The third module is Split the Train and Test Data. This module involves of pre-processed dataset and divide them into two parts of training data and testing data. The data is split into the 80% for training and 20% for testing. And the fourth module is Run Ensemble Algorithm. This module applies a group of ensemble algorithms such as support vector mission, random forest, and decision tree to the training data. Each algorithm within the ensemble is trained using the pre-processed training data. After training, the ensemble model combines the prediction from each individual classifier within the ensemble to make the final decision. The ensemble model is then applied to the testing data to calculate the classification accuracy, which measures how well the model can classify the network traffic into different types based on the learned patterns. And the fifth module is Comparison Graph. This module generates a graph that compares the performance metric of the ensemble algorithm. The graph typically includes accuracy, precision, recall, and EBSCO. Accuracy represents the overall correctness of the classification result, while precision, recall, and EBSCO provides insights into the model's performance for specific classes or types of the network. And the last and the final module is Traffic Classification from the Test Data. In this module, the ensemble model trained in the previous step is used to classify the test data. The test data, which was not seen by the ensemble model during the training, is inputted into the model. The ensemble model applies its combined decision-making approach to predict the type or class of network traffic present in the test data. The output of this module is the classification result indicating the predicted traffic type for each data instance in the test data set. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first folder is dataset folder consisting of the training network traffic dataset and the test dataset. And this is the model, and this is the main code file of type Python, and this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. Here, this is the graphical user interface. With this, we are interacting with the program, and then click on Upload Network Traffic Dataset button. Here, by this button, we are going to import the dataset from this dataset folder, and here I am selecting the network traffic data and click on Open button. Here in this screen, we get the network category graph, and here the x-axis represents the traffic types and the y-axis represents the count of each traffic type, and then close this graph. Here we can see that data is in form of numeric format and also in the non-numeric format, and we need to convert the non-numeric data to numeric data, and then click on Dataset Pre-Processing button. Here, by the data pre-processing task, here the non-numeric data is converted into the numeric data, and then click on Split Train Test Data button. By this button, here the dataset is splitted into the training and testing part. The total number of records found in the dataset is of 141530, and the 80% of dataset is used for training, that is of 113224, and the 20% of dataset is used for testing, and that is of 28306. And click on Run Ensemble Algorithm button. Here, by this, the ensemble algorithm will be generated, and we can see that of ensemble random forest J48 and SPM confusion matrix. Here in this confusion matrix, the x-axis represents the predicted label and the y-axis represents the true label, and all the blue color boxes contains the incorrect prediction count, which are few, and all different color boxes contains the correct prediction count. And now close this graph. Here, the ensemble random forest J48 and SPM gives the accuracy of 99.65, precision of 99.28, recall of 98.98, and F-score of 99.91. And then click on Comparison Graph button. By this, we get an bar graph. Here, each bar represents the one metric, where blue bar represents of accuracy and orange bar represents of F-score and green bar represents of precision and red bar represents of recall. And then close this graph and click on Traffic Classification button from Test Data. Here select the test data and click on Open button. Here for the data that is present in the square bracket is of test data, and it is classified as the file transfer. And for this test data, it is classified as of browsing. In this way, we can detect the network traffic type. In conclusion, this project demonstrates the effectiveness of using an ensemble classifier for classifying the software-defined network traffic and enhancing the quality of service. By analyzing and predicting the different types of traffic, resource allocation can be optimized, avoiding the underutilization of low traffic resources and improving the performance for high traffic applications. The comparison of the performance metric provides the valuable insight, and the ensemble model enables the accurate classification of test data, contributing to improved network management and QoS.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.